So I'm going to present But Clouds Got in My Way, Bias and Bias Correction of VIIRS Nighttime Lights Data in the Presence of Clouds. And Rajeeva, you have the time monitor on me just now. So I have 15 minutes, and please feel free to shout to break my monologue. Okay, so this is a paper that I have co-authored with 3 other people, and that's Ayush, Ajay, and Anshul. And 2 of them are physically present here, and so I can't believe that I'm repeating the thing that I've heard a lot of people say, that I'll do the presentation and you can direct all the questions to my co-authors. And I believe that Anshul is online, so we are covered. Thank you all for giving us a space to present this paper. This is an interesting and important question, and I think that it's been bubbling up for the last perhaps 2 decades, and I think that it's driven a lot by technology. The attention that has come to alternative data or alternative ways of measuring economic data has come up because of the spread of technology that captures information and makes it accessible to everyone. But in a certain sense, satellites in the sky have been there for a much longer time. And over the last decade or so, we as an economics community have been asking the question as to, okay, wow, there is this new piece of information. It's capturing data of all types about people on the ground. How is it that we can use it to capture activity on the ground without having to then depend upon local institutions, right? So if the government is doing a poor job of collecting some kinds of information, whether it's agriculture or some kinds of economic activity, for instance, where the plants are coming up all across the country, then satellite data actually gives you a source of doing this. Sorry, let me remove my mask. And there are multiple types of information that's captured by any satellite because they've got multiple sensors on every satellite, and there are now tons of satellites in the sky. The first wave of research that looked at asking whether satellite data can be a good capture of economic data on the ground was a NASA satellite which is called DMSP-OLS. What it used to do was capture one annual image or publish one annual image, and that's available from 1992. But it's one picture about various parts on the Earth. From 2012 onwards, there's a sensor called VIIRS that came up, which gives you nighttime lights data at a much higher frequency. So what is publicly available free of charge is monthly data. And it captures and publishes this from April 2012 onwards. Ayush will correct me if I'm wrong, but there is underlying data that's being captured on a daily basis. However, that's priced. This is being put out in the public for anyone to pick. So in a certain sense, this opens up economic measurement, right? You can see how there are people who are capturing new geographical landmarks in terms of where there is development by going out at 1:30 and taking a snapshot of what are the lights in a particular region. Okay, and what is published is that you've got a map with about 6 blocks, squares of data, and what we do is we ask the question, can we use nighttime lights data to tell us something about economic activity in India? Now, because it's there from 2012 onwards, you can just imagine the beautiful research questions that you can ask by looking at how much nighttime lights data are you seeing on the ground, right? You can, if you think that economic growth is being captured by more industries, even if it's services, right? You set up call centers. Call centers are going to be using electricity showing up as nighttime lights much more than compared with if you did not have these things. So it's actually a wonderful source. It is not administrative, so state is not giving this to you. It is free for use to anyone who is able to walk in and manage to compute using very large data sets. Because the data set that we are looking at for this paper is the, as I said, the VIIRS nighttime lights data. And if we look at the number of points that we have for India, it's about 16.7 million pixels. Right? And so you get information about the amount of light measured as radiance for all of these pixels across the country. And then you can see which are the brightly lit ones, which are the not so brightly lit ones, which are the ones that remain dark forever. Right? So for instance, you can think about parts in the ocean around or the seas around India where it's going to be dark. Now, what we did was to say, fine, you've got this nighttime lights data. It's just points from the sky. It's at the pixel level. How do we know that it is actually capturing information correctly? Because what we would like to say is economic data measured as lights from the sky must, in a certain sense, be useful to tell us how rich or how the income is growing or economic activity is growing on the ground. So we thought it was useful to ask the question, we've got nighttime lights data in the sky. Can we see that it correlates with income information on the ground? Now, usually this would have been a really tough problem if we were just looking at economic data published by state, but we use the CMI Consumer Pyramids Household Data Set, which is a household survey data set looking at surveying households, which is about 170,000 households all across the country, and they get 3 pieces of information about these households in a year. So we can look at that as a source for income data, and what we are looking at is to say, when we look at nighttime lights from the sky, and we see the amount of radiance in a particular region, which we call a homogeneous region, because that's how the CMI CPHS data set classifies it, then can we look at the aggregate income as well as the radiance for that region and see, is there a correlation? And because we can see both of these data pieces over time, we can say, as a region is getting richer, do we see that the radiance is going higher? Okay, because that's what we would expect, that the more economically well-off a region is, there would be more radiance. So just to describe the data set to you, there is a monthly time series. The problem is that in each month, along with the radiance, that is the amount of radiance from that particular region or a pixel, because remember, we have 16.7 million pixels for India. We can see one measure, which is the radiance, but they also tell you that in that month, how many of the days were free of clouds. Okay, so it gives you that measure. And how they capture free of clouds is up to them. So it is NASA that does the definition of how they define that, and they're quite conservative, right? That means that they are extremely stringent in how they look at a day and say, this is a cloud-free day. So for example, in December 2019, the 25th percentile value for India was that it was like less than 25th percentile of the pixels would have 10 cloud-free images. Okay, so they are quite stringent in doing this because India is a country where you have a lot of sunlight, we think, or economic activity. Most of the times when people look at this data, they understand that there are certain problems, right? So for instance, one of the things that NASA does for this VIIRS data set is, if you find a pixel which has got no radiance, right? So the value they report is 0. Whereas actually, because of clouds, they may not be able to capture the lights at all. So we do not know from the raw data whether when you see a value of 0, is it because it's a completely cloud-free place and there is no economic activity, or is it a place which has got some economic activity but it was just full of clouds that day? So that's one element that you need to adjust for. Then there are things like if you go to the Bombay High, there are these flares that happen every once in a while and you think, oh, out in the sea there's a lot of economic activity. That's not true. You'll have to adjust for that. And then we also find that there is some background noise, right? So there is clouds, they reflect some kind of light occasionally. So even if you go into the middle of the desert or go up into the Himalayas somewhere, you'll find that there is some radiance that shows up and you need to correct for that. Because remember, the objective is we need to be able to look at this data set and say, does it capture economic activity from the radiance, right? So we need to be sure that the data that we're capturing is clean of all of these things. So the first thing that this paper does is we look at the kind of cleaning that the conventional researchers have done, and we improve on that. Okay. Then what we do is we release the software that does that conventional cleaning. And once the conventional cleaning has been done on the original data set, out of the 16.7 million, we are left with 8.6 million lit pixels. And that's the base on which we're going to do our research. So here's our favorite city. This is 1 pixel in Bombay, and we want to look at how much is the radiance, which is the top box with the red lines, and we want to see how much of it is coming out of cloud-free observation days? Remember, this is a monthly data set. So every bar that you see is the height saying how many cloud-free days were there in that month. And what you'll see is a very, very strange pattern. So if you just focus on the top red line and you ask, what's happening to Bombay? What's happening to Bombay during this period? If radiance is supposed to tell us something about income, it looks like income in Bombay is going through these wild swings. But hey, Bombay is a commercial city. Behram doesn't shut his office just because it's raining. So it cannot be the case that what we're seeing as wild swings in radiance is capturing income. Right? So there's something going on here, and we'll need to correct for it if we want to be able to use radiance to capture economic activity. And that was what we started to set up, saying, how do we do this? What was nice in the pattern that we picked out was to say, look, we can see the swings up. It's funny because the swings is replicated in similar swings that you can see in the number of cloud-free observations that you have in a year. Right? So it's a 1:1 thing. So it looks like the big dip in economic activity that is measured by radiance in Bombay can be explained because there are a lot of clouds in the sky that day. Okay, so that's what we see, that every July, which is the dashed red lines connecting the radiance graph and the cloud-free images graph, tells us that it is clouds because, everyone who lives in Bombay and pretty much a lot of places in India knows that we have monsoons. And that's what's explaining, could be a potential to explain why it looks like Bombay just loses all light or income, if we are going to make that mapping, in the month of July. So we do a little more statistics to figure out whether what we are seeing visually is captured in the statistical measure. What you see on the graph over here is to say that if we look at the radiance on average in a given year, then in July, how much is it that the radiance dips? Okay, that's what is on the x-axis. And you'll see that for most part, it looks like it's dipping in July up to the tune of 30%. Right? So there's a big dip in the radiance value. And this cannot be what is showing up as economic activity. Right? We don't all see that we stop eating or going to parties or, buying whatever food that we like to eat in July. In fact, we sometimes do more of it. So what could be the explanation for this? And we can come up with two alternative hypotheses, right? Number one is that truly people in Bombay do have a drop in consumption, a drop in activity in July during the monsoons. We hate the monsoon, so we all go into bed and hibernate like bears for that month, right? And that could explain this dip in radiance. The other is that, look, actually we don't. We continue partying, but it's the case that the signal coming from the VIIRS satellite is somehow being blunted. Okay? And once again, we go back to clouds. There are a lot of clouds. Satellites are capturing light above the clouds, and somehow the amount of radiance is being dimmed because there are clouds in the sky. And remember, this is an average over 30 days, so it is there a lot of the time. So that's why, that's the alternative explanation. So number one, we all hibernate in Bombay in July, or the signal is coming out differently because of clouds. So a problem with the hibernation story is, of course, that there is also other research that shows that even if you have truly big economic activity that dims, big events that dim economic activity on the ground, the nighttime lights data takes a very long time to adjust, right? So because imagine that there is some change in a particular location that says that people start leaving. Lights that are on the roads tend to be on, right? So nighttime lights data, because remember, this data is captured at 1:30 a.m. in every region of the world consistently by the VIIRS nighttime lights data sensor. So the other research says that nighttime lights data itself is pretty stable. You can't imagine a shock that happens to economic activity that can explain that kind of change in radiance. So we're going to go back to Bombay and say, suppose we look at the average radiance every month across the years that we have these observations for, and we are looking at a period from 2014 to 2020. Is that right, Ayush?
14 to 19.
2014 to 2019. So we've got 5 years of data, or 6 years of data. And what we look at is the average radiance we calculate the annual mean, and then we say, for every month, what is the deviation that we are seeing across the entire data set? So the red line is the radiance information. The black line is our estimate of income from the data set that I referred to earlier, which is the household reported income from the Consumer Pyramids Household Survey. Now, if it is a case that radiance should be a good capture of economic activity, we presume that the same factors across months for income would be showing up in the nighttime lights or radiance data as well. But what we see here is that that's distinctly not true. Right? So we see that there is some mapping for the months from Jan to May and from perhaps September to November, but there's a big change that happens in between. And of course, if this is the pixel for Bombay, then we know that it's likely to be the explanation of the monsoon. So clouds are disturbing our ability to use radiance. You
can complete in about 3 minutes or so.
Oh, great. Okay, thank you, Rajeeva. So the seasonal factor range is another way of capturing a similar information, but because I won't spend too much time spend time on that, I just wanted to speak a little bit about how we did this. Okay, so the statistical problem with going out and saying that you have to see that there is a bias that comes in because there are clouds. The problem with saying let's understand what is the amount of that bias and then replicate or apply it across the board is that in some months when there isn't that bias or when there isn't clouds, applying the bias will introduce an incorrect measure of radiance. So you will introduce noise because the bias actually doesn't exist that month. So what we do is we look at all the pixels in India and break it up into 4 kinds of data, right? Number one, case A, where you know by definition there's low radiance. So, and that low radiance is typically removed in the conventional cleaning. Our method will not touch it. Case B is a highly sunny spot where there is sunlight all the time, there are no clouds. It's a low bias, so we say let it be. Okay? And case C is where it's highly cloudy in some parts of the year, that's like Bombay, where we say that, highly cloudy like Singapore. Singapore has got cloud cover all the time. So for instance, if we had to go and say what is the bias in Singapore's radiance, it would be very difficult to tell from the satellite data. So we say we cannot identify this bias, so we leave it alone. And the last one is Bombay, which is case D, which is both sunny and cloudy months, where you can say we can use the data to estimate a bias and then apply it. So when we do that, we need to figure out what is the statistical method to estimate the bias. And what we do here is to say, we look at the radiance, and on the x-axis we put the observation is coming from cloud-free observations or not cloud-free observations. So we see that if you have a very large number of cloud-free observations, that's the period or that's the part of the graph which is above 10. If you have very few cloud-free observations, that's a part of the graph that's below 10. So we know that if we need to apply a bias correction, it needs to be done for observations which have cloud-free observations, not for above 10, but below 10. So when there is an observation where there is very few cloud-free images, that means a lot of the data is clouded, then we apply the bias, otherwise we do not. The method that we do to estimate the shape or this relationship is called LOES. And so our bias correction scheme runs like this. For each pixel, we classify the pixel as A, B, C, or D. We then go out and estimate this function. And we say that how much is the bias that we should apply for all pixels that have radiance coming from a point where there is less than 10 cloud-free observations in a month. Okay? And that's what we use to estimate the bias. We apply the bias to the data, and then we pump it back into the radiance information. It's relatively conservative, okay, because, as I said, we are breaking it up into 4 kinds of pixels. We only do this for the pixels of the class D category. The others we do not touch, either because we don't know anything about it or because we don't have to do anything about it. Now, when we look at the adjustment, remember we talked about this graph. The black line is the income, which is what we believe is the truth. The red line is what we saw as the unadjusted conventional data on radiance. What we see are 2 more graphs in this picture. Okay? There's a purple line, which is a dashed line, where World Bank publishes a data set about economic activity mapping back to radiance. So they publish this data for VIIRS nighttime lights, and that's the purple line. You'll see that there is still a big dip in the purple line, which is close to, which is far away from black. The blue dashed line is our scheme, right? So when we apply this bias correction in a somewhat nuanced, conservative manner, we are getting up with the radiance which shows seasonal patterns that look similar to the seasonal patterns of income. This is for 1 pixel, which is Bombay. This is for doing it all across the country. Okay? So you'll see that even for all across the country, the black line is the income aggregated across India. The red line is the conventionally cleaned radiance from VIIRS nighttime lights. The purple line is the World Bank, and the blue line is our scheme. Right? So it looks like there is an improvement. It's not perfect. There is still a gap between what we see as ground truth, that's true income, and the amount of income proxying, the radiance proxying income. But it is much better than the other alternative measures for radiance coming from the VIIRS nighttime lights. So that was for the seasonal pattern. Then I thought I'd show you some pretty graphs, which is what happens when you adjust the radiance coming from VIIRS nighttime lights as a time series from 2014 all the way up to 2019. And you can see it, right? It looks like Bombay is dipping crazily in terms of radiance all through these years. But when you do the bias correction, the crazy dips are muted. Remember, it's not going away, but the crazy dips are muted. So we think that we have added value in how a researcher can use radiance to now start detecting economic activity. This is for Bombay, and we thought, look, any good research is one where you should be able to generally apply it all across the world. And because you can get these nighttime lights data for any point in the world, we thought we'd look at some cities which could be candidates for A, B, and C as well, right? So we looked at Dubai.
Time is way up now.
Yeah, I'm sorry. So I'm going to wrap up. I just wanted to show people the pretty pictures. 1 minute. I won't say 30 seconds. And so this is Dubai, where we have no clouds. And you see that there's no difference between radiance and our method. This is Singapore, where we don't really have any value add. But whatever we are doing by way of the conventional cleaning methods that we put out in the public domain, we have some kind of a benefit. And this is aggregate radiance for all of India. Right? So where we see that there is some amount of substantial benefit. And just to link it back to the ground truth story, the black line is income for India for these years on a monthly basis. Our scheme is way up there. It shows that India is doing a lot better than the income captured from the ground, but it's doing better than the World Bank scheme, which is the purple line at the bottom, which actually looks like there's no growth in income in India at all. Therefore, we believe that we have contributed in terms of improving on the data, on the method or on the data. We've released some packages that are available in the public source. Ayush, who's sitting right across me next to Shubho, is the person who's the author of that package. Please talk to him if you want to get access. These are the authors. Thank you very much for your time.
So, I'm going to speak far less than 10 minutes, so that's why I was a bit more relaxed in timekeeping.
Thank you, Rajeeva.
All right. So, this is an extremely important paper, and the idea that nightlife can measure overall activity level, including economic activity level, has been around. So I hear. I did not know that. I came to know that when I saw this paper. But again, the idea is there, but the devil is in the details. And so the importance of this, in my view, is that it could give us instant feedback on economic activity well before any survey can be completed to get this information, which in turn is way before government releases this information. So it could be an investor, it could be policymaker, anyone who is interested can have a very fast feedback on this. So therefore, it's an interesting as well as important enough issue. Of course, to get to that connection, it requires one to develop a relationship between the nighttime lights and the economic activity, which in turn leads one to identify auxiliary variables that may be involved in the relationship and develop way of estimating the variables if they are not directly available. Some of these auxiliary variables could be directly available, some you may need to estimate, and the statistical way would be to complete this entire picture. Okay, and so I'll mention what can be called naive thoughts on this, because this whole idea of connecting nighttime data and electronic and the activity was new to me. So I've basically only read this paper and I've come up with some thoughts. Some of them may be already answered by others, or maybe even in this paper, which I may not have read that carefully, or they have already been thought by the authors but have not yet been implemented. Okay, but I'm mentioning them to initiate a discussion and a thought. All right. So my view as a statistician, so I guess I'm the only non-economist in the gathering, perhaps. So as a statistician, is that the nighttime activity, along with few other variables, can give a reasonable estimate of economic activity, but those few other variables, I put it in red because ignoring them, it will lead us astray. So what are these? So of course, first and foremost is the most obvious one is the one identified by the authors, impact of cloud or rain on the nighttime activity by a satellite. Okay. As it turns out, I had written cloud versus rain, but now after listening to Suzanne, the rain is not important. It is basically the cloud, because clouds are what is preventing the satellites from picking up the data. All right. So the impact of rain, if any, will be minimal. The cloud will be the major one. All right. So this has been addressed by them, and maybe over time it can be even improved by the authors, but they already made a very good beginning, and one could see from the various charts that Suzanne showed that it's already doing better than the raw methods. Okay. Now, I have a few more things to add. One is the country. The relationship will depend upon the overall activity in the country and the overall cloud things in a country, in my view. At least this should be explored, even if it is going to be ruled out. So, for example, if, as they have done in the paper, compare with look at Dubai and Singapore and with India, if you have to compare that, we must bring in the fact that these are coming from different countries. The economic computing is different, economic views are different. I don't know. Before we rule it out, we should explore. So whether the country is important or not. Now, another important factor in my view is it an urban or a rural area, or what percentage of area within this homogeneous region as put in the CMI database, the HR, what proportion of HR is actually urban area, and proportion geographically, proportion economic activity wise, both. And for Bombay, it will be highest in the country. Whereas if one goes to one of the other HRs which have been mentioned, the Jhabua Nimar HR, it turns out that I'm born and brought up in MP, and this area is not that far, and I have actually traveled to this area, though years ago. So I can say with authority that these are, there is no big town there. There is all small areas, smaller towns. Big towns, of course, definitions can vary, but in my view, okay. So the way the economic activity and clouds interaction would be different from Bombay and from this area, and somewhere this has to be factored in. Okay, how to measure, how to do is the next question. Perhaps one can look at, say, by looking at Bombay, one thing could be simply look at the last 5 years data, compare them with economic activity and the nighttime activity, nighttime light activity or measurement. And second would be to also compare across the whole country, and maybe convex combination of the two. I don't know. So somewhere this factor that this is urban or not should come into the picture, because it may determine how the economic activity is related to the light. All right. So the other thing could be, if for the main effect only, ignoring the other things, the main effect would be the disconnection, nighttime light and economic activity. Other thing to do would be, we can just look at the months outside the monsoon months, maybe 8 or 9 months outside the monsoon months. We do it across the years and develop a good connect between these two, and then come back and see how it relates to the bias. So this could be another way one could try. And if for these 9 months, then one can compare this with the connecting for 12 months, connection for the 12 months after the bias. So if we feel that the connect between the economic activity and the nightlife for the off monsoon months is good and continues to be more or less the same after the bias correction for the whole, that would be evidence that correction is working very well. If not, that tells us that maybe we have to apply something more for the correction. So, and then as I mentioned already, one should estimate effect of a country, especially if you are comparing multiple country data. Other important fact, most of us in India are aware of the southwest monsoon. And I heard about the northeast monsoon only after I moved to Chennai about 11 years ago. First time when I read, what is this northeast monsoon? You have never even heard about it. But it is there. It has an impact, especially in the Chennai region, maybe in some other regions too, but certainly in the Chennai regions. And the time frame is October to December. We have far more rainy days now than in the July-August time. And this brings in another interesting aspect that given that these two time frames are distinct and their impacts are distinct, that may give us some more statistical thinking in the data, in bringing the connection between the two. So, last thing could be whether zones, and even more so than later state-wise, at least the big states-wise, do they have some impact? Or is it only economic and is it only urban and outside urban? So again, dividing the country in zones and applying these corrections and seeing, checking may give us an idea. But these are all exploratory steps. None of them is definite. Most of it I have thought about, to be honest, yesterday when I knew that I have to speak today. So hope it is making sense, and hope we can, Ajay, Suzanne, and the other two, you can take at least some part of these suggestions. So, so this is a great beginning, and perhaps over time we can estimate these things even better. Thanks. That's all from me.
Thanks a lot, Rajeeva, and thanks for the time that you gave back to us. I think that I'll open the floor to questions. I think Behram is one. I'm glad I persuaded you to stay.
Thanks a lot. Rajeeva, thanks a lot for that. I have to say there's certainly a non-economist in the room. As a statistician, I guess you're a sibling or cousin. I'm not sure as a lawyer I'm related at all. But whatever I know thanks to Susan and Ajay. Susan, two quick questions. One was that the pollution, smog, whatever you want to call it, does that also, for example, Delhi in December, Jan, we know, or you can barely see 3 cars ahead of you. I'm not sure whether the satellite images pierce through that. And the second one was your graph showed as if, radiance, if I understood it right, keeps going down the first 6 months of the year and then goes up the second half of the year after the dip in July. Is that a right reading, and is that really the way the radiance pattern is? Because it kind of doesn't make sense. And the other one was 2020, which was of course a very bizarre year. It showed that sharp dip, But there was also a dip both in the radiance and the income, which we know because of the lockdown. But again, I don't know whether that was there too much noise there, or did it make sense? So those were my two questions.
Thanks a lot. I think Pavan has also got a similar question to yours, Behram, about the AQI affecting the lights or the amount of radiance that we can get. So I'm going to toss the AQI question to Ayush because he's an AQI freak. But what I'll do is, Rajeeva, I mean, completely on board, right? So we don't know this because even though the use of nighttime lights data to capture economic activity has been an idea that has been spinning in people's brains, and there's a lot of research, not just by economists, to use it as an activity indicator. It's something that's been spinning for the last 10 to 15 years, so there's nice literature on it. It's not clear that it automatically can be used in the way that we would like to, right? So that's why we stressed a lot, saying that we need to figure out how clear an indicator of economic activity this is, and let's see all the problems that can come up. So I do not know whether we've looked at, I don't know whether there's a literature out there that looks at how it can vary across countries or regions. My sense is we're going to have to develop some hypothesis as to why that should be the case, right? We say light is light. Other than atmospheric effects, why should it be the case that it should not be an equivalent indicator across countries? Maybe by looking at radiance as opposed to reported income, we can say what is it that explains the difference. I don't know, but my sense is that's open territory, at least for us. Perhaps Ayush can tell us a little differently because he's read the literature a lot better. On the question of the point that you were brought up close to Jabwa Nimar. That's great. We should figure out a way to converse, because the reason why we started looking at this problem was because we looked at the radiance data for Bombay and said this cannot be. Right? So the knowledge and awareness of ground truth is really important to validate or dismiss sources of information about economic activity on the ground. So notwithstanding the things that it can be blunted or attenuated by various factors, ground truth is very important. We need to be very careful about how we read radiance data before we start making policy and reading stories about it. So one more thing is on the pattern that we see, right? You know, we even question what that pattern is or why it should be, because we are trying to link it back to economic activity. If we just looked at that graph as it is, you'd say, okay, fine, that's how it is. We are trying to say, how can we read that information to tell us something about economic activity, and then we get perturbed by the fact that it dips down and comes back up. So our sense is, suppose you were to think about some norm of economic activity, then yeah, the clouds come in, cover the signal about economic activity, and then it comes back up, right? Should it come back to exactly the same point? That's statistics. But I mean, by itself, there's nothing that makes us disturbed about that. So can I take Renuka's question before we come to the AQI story?
So, Susan, a lot of economics papers have used the World Bank measure of nightlights to make comments on economic activity. And now you're finding that there is a bias. It's not correcting for the cloud cover. So my question is, to what extent do you think that this bias that you have corrected changes our view of whatever results we've seen in the past, especially if you start doing district fixed effects or state fixed effects, then you're only looking at variation in that district, and then does that bias really matter?
Correct, right? The thing that I would like to say is, from the point of view of this method, we are very clear that this method doesn't improve anything other than for one set of pixels, right? So we are very careful. The rest of it is what it is. And so all the World Bank data that is being used, or studies that are being done on the World Bank data, the question is, how much do they focus on Class D pixels or Class D based countries? And I think there we should be careful about what those results and the inference is. So for studies on India, yeah, I'd say let's worry about it. But if there's a country where that's not so much of an impact, I don't know. We'd have to, this is research, at least for us as economists. Sorry, Ayush.
So before the AQ question, I think the... Can you hear me now? I think we're not covering the 2020 lockdown period, so maybe there's a confusion. For the AQ question, from a physics point of view, I don't think AQ will affect light because the VIIRS sensor captures infrared light, and then for scattering, the size of the particle should be comparable to the size of the wavelength. So I don't think that it will matter, but we were thinking that this should be one of our future papers, that we should explore this. That yeah, perhaps there's a relationship. Perhaps there are also bigger particles because we only see PM 2.5 and PM 10, and maybe there are bigger particles also. They aren't as harmful, but maybe they exist at the same time. So we were thinking about a paper on that, but my sense from a physics point of view is that it will not affect. Any more? Yeah.
Can I ask a question on the Susan?
You want to do the 2020 answer, Ayush, or do you?
So
Sorry,
we-
Yesha, just give us a second.
We've-
A minute.
We've only studied from 2014, Jan 2014 to December 2019. So that was, I think, before the.
So this is yet another future paper. The number of future papers in our future is just tremendous. Yesha, please go ahead.
So this is an amazing paper. Just like Rajeev was saying, that this is a fascinating area. And you know, when I saw the titles, I didn't exactly know what was going to come, and this is just an incredible presentation. So I had two observations. So one is that if you fly over North Korea, everything goes dark. So, you know, once you are on the plane and you cross from South Korea to North Korea, you'll see like the entire country go completely dark. And, you know, that doesn't necessarily suggest there's no economic activity in North Korea. It just means that there's a governance issue there that suggests that they do things to reduce the light. So, for example, in North Korea, they reduce light in order to stop people from mingling at night. So, you know, there are reasons that relate to, you know, why light exists within certain jurisdictions. I wonder whether there's a governance story that could possibly explain, in certain contexts, in certain regions, in certain environments, that light has a particular sociological significance and a governance significance that may be interesting to study. And the second question or, you know, discussion I would love to see in this paper is an analysis about the implications. What exactly is the payoff that you guys are looking for from the policy perspective? Once you are able to isolate this as a signal of economic activity, what's the kind of end goal here in terms of what you want this data point to do? Is it a way to, you know, be informative for hedge funds or whatever that want to have an edge, or what's the end point here?
So, Yesha, to the first question, and I guess you're right, Rajeeva raised it as well, right? Is there some element of the country itself, characteristics of the country that can explain the difference in radiance? And I think that what we are very careful about with this paper is that it's the first step in acknowledging that when you use this data, you need to be careful. Right? And we propose a method to take care of one kind of problem, which is the cloud problem. The next series of papers is that now that we are a little more confident about what is the kind of information that we're capturing about economic activity using the radiance data, we will indeed start asking the questions that you and Rajeeva are asking us to do, right? Why is it that just across the border from one country, you see that there is such a significant drop in the amount of radiance? And perhaps it's governance. So Rajeeva's point about let's look at all the other variables to explain the radiance is exactly what we will be able to more confidently start doing now that we've understood how to read this data. So this is just the first step. The ground truth papers are just waiting to happen, and that's the follow-on thing. What was the second question? The payoff. Oh, so for the payoff, it's like this, right? We don't, we know what the payoff is for us because we're answering all these questions. What we do know is that we are putting out public domain software that then anyone can use to look at nighttime lights data. We are hoping that more and more people will use this software, and eventually, maybe 2 or 3 years down the line, we'll understand what the payoff is in that kind of terms. But we think that reading this information is critical. Because it's out there, it has great scope to tell us about economic activity, then how different people use it. Like the lawyers will use it, or the political economists will use it, or the fund managers will use it, is actually up to their imagination in a certain sense. We just think that if it does indeed capture economic activity, then an entire choice set opens up that we weren't able to capture before. As Behram said, or Rajeeva, I forget whom, it's more real time, right? You can actually see things, the reality changing on the ground. But yeah, that's the next set of questions, which is the ground truth linkages. I hope that answers. And thank you for the discussions. Thank you for the questions.